Yeah, recording started.
Okay.
Okay, yeah. In a screen share ഇത് start ചെയ്യാം. Yeah. Resume slideshow.
Okay അല്ലേ?
Yes. Now it's okay.
Okay. 2 മിനിറ്റ് കൂടി ഉണ്ട് അല്ലേ?
ഇബൽ സാർ ഞാൻ സൈൻ ഔട്ട് ആവാണേ.
എന്ത് പറ്റി?
ഞാൻ കുറച്ച് കഴിഞ്ഞിട്ട് ജോയിൻ ചെയ്യാം.
Okay. Nizam sir, are you there? Nizam sir.
F star g of t ആണ്. ഇത് f star g of t equal to integral 0 to t minus u f of t minus u അങ്ങനെയുള്ള. പിന്നെ അതിന്റെ പ്രോപ്പർട്ടീസ് കമ്മ്യൂട്ടേറ്റീവ് ലോ, പിന്നെ
Joseph, good morning.
Good morning, Rubesh.
Yeah.
കേൾക്കുന്നുണ്ടാ?
Yeah, okay. It's clear.
Thank you. അപ്പോൾ സമയം
രൂപേഷ് സാറേ,
Yeah.
പിന്നെ അൺമ്യൂട്ട് അല്ലാതെ ഏതെങ്കിലും ഉണ്ടെങ്കിൽ അതൊന്ന്.
ഞാൻ മ്യൂട്ട് ചെയ്തു.
ഓക്കെ.
ആ സ്ക്രീൻ എനിക്ക് ഇവിടെ വിസിബിൾ ആണ്. സെയിം സാധനം നിങ്ങൾക്ക് അവിടെ കിട്ടുന്നുണ്ടോ?
കിട്ടുന്നുണ്ട്. എനിക്ക് മ്യൂട്ട് ചെയ്യാൻ പറ്റുമെന്ന് നോക്കട്ടെ.
അല്ല ഞാൻ ചോദിക്കുന്നത് എന്താ വെച്ചാൽ ഇപ്പം ഹാർട്ടി വെൽക്കം എന്നുള്ള സ്ലൈഡ് കാണിക്കുമ്പം നടുക്ക് മറ്റേ പാർട്ടിസിപ്പൻസിന്റെ ഒരു ലിസ്റ്റ് കാണിക്കുന്നുണ്ടോ നിങ്ങൾക്ക്?
അല്ല, എനിക്ക് പാർട്ടിസിപ്പന്റിന് മറ്റേ ഇത് എടുക്കാലോ.
അല്ല ഞാൻ അതല്ല ചോദിക്കുന്നത്. എനിക്ക് ഇവിടുന്ന് പാർട്ടിസിപ്പന്റിന്റെ ലിസ്റ്റും കൂടി ആക്സസ് ചെയ്യാൻ പറ്റുന്നുണ്ട്. പക്ഷെ ഞാനത് ആക്സസ് ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് ഈ ഹാർട്ടി വെൽക്കം എന്നുള്ള സ്ലൈഡ് മറിഞ്ഞുകൊണ്ട്
ഇല്ല അതൊന്നും ആവുന്നില്ല. അത് അവിടെ തന്നെ ഉണ്ട്.
ഓക്കെ, നോ പ്രോബ്ലം. അങ്ങനെ വെച്ചാൽ എനിക്ക് കൺട്രോൾ ചെയ്യാൻ പറ്റുന്നുണ്ട്.
അവനോട് ജോയിൻ ചെയ്യാൻ പറയട്ടെ.
പറഞ്ഞോളൂന്നാ എനിക്ക് തോന്നുന്നത്. പ്രിൻസിപ്പാൾ എടുത്തു ഒന്ന് പറയണോ?
I joined Rubesh. Already joined. Okay. No problem. Okay. നമ്മൾ തന്നെ കാണുന്നില്ലല്ലോ നമ്മള്. രൂപേഷ്, എന്നെ കാണുന്നുണ്ടോ?
സർ എനിക്ക് കാണില്ല, കാരണം ഞാൻ സ്ക്രീൻ ഷെയറിംഗിലാണ്.
ഓക്കെ.
സുബേർ സർ, പ്രിൻസിപ്പാളെ കാണുന്നുണ്ടോ?
കാണുന്നുണ്ട് സാറേ.
കാണുന്നുണ്ട്.
ഓക്കെ.
സാറേ, ഓൻ ജോയിൻ ചെയ്തിട്ടുണ്ടോ? ഹരീഷ് സാറെ ജോയിൻ ചെയ്തിട്ടുണ്ടോ?
സാറുണ്ട്, ജോയിൻ ചെയ്തിട്ടുണ്ട്.
ഫരീദ്, അറിയില്ല. ഫരീദ് സർ, ആർ യു ഹിയർ? ഹലോ.
ഫോണിലൊന്ന് വിളിച്ചാറേ. വാട്സപ്പ് ഇട്ടാ.
അല്ല അതില് ഓന് ജോയിൻ ചെയ്യാന്ന് പറഞ്ഞിട്ടുണ്ട്.
ലിസ്റ്റ് നോക്കി അറിയാലോ.
ഡിസംബർ 31.
Yes, sir. Good morning to all of you.
Yeah,
I'm
Farid,
audible.
welcome, Farid.
Yes.
Okay, yeah.
Yes, I'm audible. Yes.
Okay, so audible, right. Sir,
Thank
can
you,
we
sir.
start now?
Yes.
Okay. Principal, sir?
Yeah, okay. You start.
Okay.
Okay, good morning to all of you.
Sorry, Farid.
Yeah, good morning. Good morning, Dr. Farid. I'm principal. Okay.
Yeah.
Welcome to PSMO. Okay.
First of all, I would like to express my thanks.
Farid, just a moment,
Yes.
Farid.
Yes.
Okay, we have to move to some official format. So let me express the welcome address. Yeah.
Okay.
Okay. Good evening. Good morning, all of you. I'm extremely happy to welcome all of you for this international webinar on fixed point theory. In this era, COVID era, especially lots of booms and booms are there in webinars. So this webinar won't be, I request all participants kindly mute your microphone. Participants, please mute your microphone. Okay. So why we taking this fixed point theory this much of importance? That's the first question we can arise in your mind. The simple answer is that after studying so much of theory, our students
Rubesh.
Yeah, is it audible now?
Yeah, now audible. Okay, you continue.
Okay. Our students, after finishing the PG itself, they are repeatedly asking us what is the need of such theorems or what is the practical applications. The tragedy is that we are studying only the theoretic part of the mathematics. The applied science we are not at all touching. So this fixed point theory finds lots of applications. As you know that differential equation, one of the core or the cream of mathematics, find many application in physics and some other areas. So fixed point theory assures that this differential equation has got a solution. I am referring only one application only because our resource person is there to explore a lot of applications. So this is the importance of fixed theory in this scenario. Now let me move to my duty. First of all, let me welcome our beloved principal to this international webinar, who was the driving force to us. We are very thankful to God to get such a wonderful principal with us, who is very much supporting in each and every activities of our department. And the next one, today's attraction, that is today's chief guest or today's the resource person, Dr. Mohammed Farid, Assistant Professor from Kasing University, Kingdom of Saudi Arabia. I welcome you, sir, for this wonderful occasion. We are very eager to hear from you all the fixed point theories and its applications. And let me welcome all the participants, that means the teachers from various colleges, my dear colleagues and research scholars and dear students. A heartfelt welcome to this wonderful webinar. And let me also welcome our IQSC coordinator, Nisamuddin sir, who has given all the support for conducting such a webinar. And Basim sir from physics department, who was from the beginning itself, who was always supporting us for this. And all the faculties and all the students. I should name one, Shamim. He was our BSc student who took a keen interest to designing and all, designing our brochures and designing our certificate, everything. He was standing shoulder to me for that and everything. And all my colleagues, everyone, welcome for this wonderful session. And now I am moving to our beloved principal, kindly to inaugurate this international webinar, sir.
Okay, Rubesh, audible?
Yeah, audible, sir.
Okay. Good morning, all. Most respected resource person for the day, Dr. Muhammad Farid, Assistant Professor, Department of Mathematics, Qasim University, Kingdom of Saudi Arabia. Dear Dr. Rubesh, Head of the Department of Mathematics, PSMO College. Dear Nizamuddin Kunnat, IQAC Coordinator. Other faculty members joined from different colleges. I noted few names. Dr. Bijumon and my dear friend Dr. Prajit from Malabar Christian College. Former HOD Suharabi. Dear faculty members, research scholars, and dear students. Once again, warm good morning to one and all. Very happy to see that the oldest department of PSMO College organized an important webinar at international level today. We all know, we all are suffering from the bad effect of the pandemic. The academic year 2021 has already moved to its final lap. We reached already completed more than 70% of an academic year. Every year, the Department of Mathematics used to organize some important activities, some seminars, workshops, etc., for the benefit of students. Lot of programs they used to organize. This year also, I am sure the department waited until the final lap to organize one or two programs at offline mode, because we all experienced a season of webinars during from June to November. All colleges organized a lot of webinars on different topics, and situations is not changing, but some decisions are coming about the reopening of college. Anyway, I already mentioned the oldest department. I consider this program as an important one, and also I take this opportunity to congratulate Dr. Rubesh, the head of the department, and other faculty members who worked sincerely for the success of this program. And with regard to that brochure, I already shared to Rubesh a good brochure. That means this webinar is not for namesake. In that brochure itself, it is very, very clearly given about the seminar topic and also about the resource person. From that, I understood today's resource person, who is an expert in the topic mentioned, fixed point theory. I am not at all familiar with the mathematics. Many occasions I shared the subject that I fear very much in my life is mathematics. And also I got some idea about the topic fixed point theory because it is connected with the PG syllabus and also the research area, and also connected with many areas of mathematics and also some other subjects, economics, econometrics, etc. Anyway, it is not having any connection with the botany, because I'm a botany man, hence I'm not a person to say about the seminar topic. Anyway, I wish all the very best to Dr. Muhammad Farid. Sir, this college, Poker Sai Memorial Orphanage College, established in 1968. We are moving to its 54th year of existence. One of the oldest colleges affiliated to University of Calicut, elder to University of Calicut for 1 year. And also I request Dr. Muhammad Farid, we are planning to change this department into a research center within 1 or 2 years. We are waiting for a few more PhD or faculty members. By that time, we are planning to change all our departments to research centers at PSMO College. And also, I request Dr. Muhammad Farid, sir, we need your help and support in future years for the development of teaching and research in this college. And also, sir, I invite you to South one day when the bad effect of the pandemics were over. And also, I invite you to this college, PSMO College, one day in the near future. With these words, I thank all faculty members who joined from different places for this today's webinar, and I request our students, PSMO College students, to make this program a good one, interact with the faculty resource person, because he is a genius in this topic. I noted from his PhD and other areas, and also his publications. A man with a lot of publications. He's very young, a young man, a young energetic fellow. From his video, we noted. And also within this time, he published many publications in very, very important journals. And also, I request all participant students to make this program a good one, interact with the resource person, and try to grab a maximum out of today's webinar. Once again, my hearty congratulations to my faculty members in the Department of Mathematics. With these words, with full of happiness in my mind, I'm very happy to inaugurate today's webinar on the topic fixed point theory. Thank you very much.
Thank you, sir.
Dr. Rubesh.
Thank you, sir. Thank you, sir. Let me invite Jaffa, Assistant Professor, Department of Mathematics, PSMO College, to introduce the resource person. Jaffa, sir, please.
Good morning. Audible? I am audible?
Yeah, audible, sir. Audible.
Good morning to all. Respected Principal, PSMO College, Tiruvangadi. Our most respected Chief Guest, Dr. Muhammad Farid, Department of Mathematics, Qasim University, Saudi Arabia. Dr. Rubesh, Head of the Department of Mathematics, PSMO College, Tiruvangadi. Nisam Kunat, IQC Coordinator, and all other participants. Now, I am very happy to introduce our guest, Dr. Muhammad Farid. He is from Uttar Pradesh. Now, he is working as an assistant professor in Department of Mathematics, Deanship Educational Services, Qasim University, Saudi Arabia. Dr. Farid completed his PhD degree in 2014 from Aligarh Muslim University, Aligarh. He has active researcher in functional analysis and allied areas. He has published more than 20 research papers in reputed international journals. Also, there are 5 research projects is completed under his supervision. Also, he is an editorial member of the journal Vehicle Dynamics, and he is a referee of the many journals like the Korean Journal of Mathematics, Asian European Journal of Mathematics, JMI International Journal of Mathematical Sciences, Advances in Differentiation. And also he is conducted and attended many national and international conferences and workshops. Welcome, sir. On behalf of all participants, I invite Dr. Muhammad Farid to deliver his lecture. Welcome, sir.
Sir, kindly unmute, sir. Faris, sir, kindly unmute here. Faris, sir, kindly unmute your microphone. Okay, thank you, sir.
Okay. I am audible, sir?
Yeah, now it's audible.
Okay, thank you so much, sir. So now let us start.
Yeah.
Okay, so okay, dear sir, good morning to all of you. First of all, I would like to express my thanks to the principal of the college, Dr. Aziz K, and head of the department, Dr. Rupesh, and my colleague, Mr. Subair Kuniel, and to give me opportunity to deliver a talk on fixed point theory. And also, I would like to thanks for your kind words, sir, Dr. Aziz, and also Dr. Rupesh and Dr. Jaffrey. Thank you so much, sir. So let us start. Now I share the screen. Just a minute. It is or visible, sir?
Yeah, visible, visible.
Okay, thank you, sir. So, dear student, today topic is fixed point theory. So basically, we discuss about the first of all, we discuss the concept of the fixed point theory, fixed point and their example. Okay. This is the outline of my lecture. So first of all, we discuss about the concept of the fixed point. Then I will give some basic examples, and then we discuss about some important theorems on the fixed point theory and application of the fixed point theory, and then finally the references. So now let us see the definition of the fixed point. Here I consider X as a non-empty set, and I consider F as a map from X to X be a mapping. A point, any arbitrary point X in X is said to be a fixed point of F if F of X equal to X, that is X is invariant under the transformation F. So here it's a geometrical figure I have shown here. If you want to find the fixed point of any function, you can also see its intersection of the line y equal to x. So here you can see here the intersection, that one is the fixed point of this function f of x. Now you see here, there are some examples I have taken. Let x equal to r. Here r denotes as usually you know denotes the real number. We are non-empty set, and t is a map from x to x, and it defined as a tx equal to x plus a. For some fixed number a, then in this case it has no fixed point. We cannot find. Definitely here actually we have taken a as a non-zero. Otherwise, if you consider it as a zero, so zero will be the fixed point. So definitely here I consider as the I consider as the a is non-zero. Okay, then, if I consider a as a zero, so definitely it has the fixed point. Okay, now we come to the next example. Here x equal to r be a non-empty set, and this is a map defined as a 1 upon 2x. Then in this case, x is 0 is the only fixed point of t. Another example, if I consider the mapping tx as a x square, So in this case, you can find 0 and 1 are the two fixed point of t. Another case, if I consider tx equal to x, that is the tx equal to x, then in this case, it has a infinitely many fixed point. Here, from example 1 to 4, actually, I would like to tell you that uh, uh, mapping, actually a mapping, it has maybe one fixed point, maybe no fixed point, maybe more than one fixed point, maybe infinitely many fixed point. So here I have written the conclusion. From the above example, we notice that a mapping may not have any fixed point, may have a unique fixed point, may have a more than one fixed point, or infinitely many fixed points. Here the second point, suppose that we define the mapping, because before it very simple. Now suppose that like this 2 minus x squared to the power 1 by 4, and I would like to find its fixed point. So you can solve, then its fixed point is the solution of the equation x to the power 4 plus x is minus 2 equal to 0. So it's very simple. Just you here the left.
Sorry, Farisa. Once again, I repeat, all the participants, please mute your microphone. It's causing so much of disturbance.
Yeah. So the left hand side, you just put as a x if you want to find the fixed point of any mapping. So whatever the right hand side, you just put here left hand side tx as a place of tx as a x. Then as usual you can solve it. Okay. Then the value of x, that one gives the fixed point of t. So it is actually here. It may be any power. Okay. No problem, you can do it. So just you put here left hand side as a x, and then you solve the equation by any methods. So now we come to the fixed point theory. That one is the concept of the fixed point. Now we come to the fixed point theory. Basically the fixed point theory divided into three major area. First one is the topological fixed point theory, and second one is the metric fixed point theory, and third one is the discrete fixed point theory. The Banach construction theorem is one of the important and useful result in the metric fixed point theory. In the study of analysis, this theorem most widely used because of contraction condition on the mapping is simple and easy to verify, and it finds almost annual application in the theory of differential and integral equation. In the last, I have given the example of these two, that how can you use the Banach construction theorem. So basically today we have discussed about the metric fixed point theory. Okay, so that one is the actually we used in the Banach construction theorem. So now here, before discuss about the Banach construction contraction theorem, I would like to discuss recall some definition. If I consider x as a non-empty set, so a real valued function d from x cross x on x cross x, it is said to be metric on x if it satisfies the following condition. So here d of x y, it is greater than or equal to 0. It is also say the non-negativity condition for all x y in x. Here it is called the nullity condition, d of x y equal to 0 if and only if x equal to y. Actually basically this one we use as a distance. If you are talking about on real number. Okay, so that is distance of x and y, between x and y. So I'm not going to that one. So now you see here d of x, it is equal to d of yx. This is called the symmetric condition. And d of xy is less than or equal to d of xz plus d of zy for all x, y, z in X. This is called the triangle inequality. Now here the system, this X with D, it is called the metric space. This function D, it is called the metric. And if I take the set with metric, so it is called this system, it is called the metric space. I have given some example here, some basic example. Suppose that here if I consider as a
Sorry, sir, again you got mute.
now it's okay, sir?
Yeah, now it's okay.
Okay. Now you see here in this example, I take x as a real number, the set of integer, and I define the metric as a mod of x minus y for all x, y in X. Then xd is a metric space. We can verify all the four conditions as we mentioned in the previous slide. And the metric D is called the usual metric. Here in this case, this is called the usual metric on a real number. This is by the same way we can define on the complex number. I'm audible, sir?
Yeah, it's audible.
Okay, thank you. Okay. Next, let xd be a metric space. Next definition. Just I recall because of I need it in the Banach construction theorem. A mapping T from X to X is said to be Lipschitz continuous if there exists a constant alpha, positive constant, such that this condition satisfy d of tx, ty, it is less than or equal to alpha, dxy for all xy in X. Here there are some remarks. If I consider alpha as a 1, so this mapping T is said to be non-expansive. If we consider alpha in 0, 1, so it is said to be contraction. So by this one non-expansive, by the term also you can understand it. Here is the contraction, that is you contract, huh? The meaning expand, that is non-expand. Okay. So here, if you consider if d of txy, tx, ty, it is less than, that is strictly condition here you impose. So here d, it is less than d of xy for all x is not equal to y. So we say this t as a contractive. Now here from it is obvious that Lipschitz continuous, it is always continuous, but the converse not true. You can take an example like tx equal to 2x, 3x. Okay. Contraction mapping, it is always contractive, but converse may not true. I have taken here, I have given an example. If you consider the metric semi-closed interval 0 to infinite with the usual metric, already we discussed before it, when t is a map from x to x and defined as like this, then it is a contractive but not contraction. You can check it. Now we come to the most important theorem of the fixed point, Banach correction theorem. So here the statement is, let xd be a complete metric space and T is a map from x to x be a contraction mapping, then it has a unique fixed point. Okay, so because of its importance, I would like to share its proof. So how can you, because of its uh, after that I will show you its importance. So actually I would like to share the proof. So how can we prove it? So see here, for the proof of this one, I consider a sequence xn and use the iteration. Okay, that one is also we call as a Picard iteration. We our construction of the iteration, that is the Picard's iteration. So choose any arbitrary point x0 in x. Then here x0 is not equal to tx0. Sure, actually if you consider x0 equal to tx0, so nothing to prove. Now we define here xn equal to t of xn minus 1. This is also called the Picard iteration, this type of the construction. So for all n belongs to natural, n for natural number. Okay, so now you see from here, xn equal to txn minus 1. You can see here x, if you put x1, you can find x1 equal to tx0. Like this you can make the construction x2 equal to tx1, x3 equal to 2tx2, like this. Okay, so this one we use after that. Now here claim, we have to prove that this sequence xn, we have whatever you consider as a Cauchy sequence. Since it is a contraction mapping with Lipschitz continuous, I use as a alpha belongs to 0, 1. So for all p as a natural number, we have we can see here by using the construction d of xp plus 1 xp. We can use the previous our construction. Already we have constructed, we have taken the iteration. So at the place of xp plus 1, we can use a exp. And because you see here, already we have here defined xn is txn minus 1. So by using this one, we can here put x at the place of xp plus 1 as a txp, and xp as a txp plus minus 1. Then we use the contraction mapping definition. So it will be alpha dxp xp minus 1. By the same way, we can apply here. Okay, so finally we got, by the same way you apply, then we got alpha to the power p dx1 x0. We continue the same process. Okay, we use the contraction definition of the contraction and previous supposition. Okay, so here alpha to the power p. So if dxp plus 1 xp, it is alpha to the power p dx1 x0. Now here, let m and n be any two positive integer with m is less than n. Then by using triangle inequality, here triangle inequality, as you know, before it we have discussed, we can find from here alpha to the power n over 1 minus alpha dx1 x0. Now you see here, since limit n tends to infinite alpha n, this is 0, and dx1 x0, it is a fixed. Therefore this dxm xn, this tends to 0 as n tends to infinite. So this shows that xn is a Cauchy sequence in x. As x is complete, therefore there exists x bar in x such that xn is converges to x bar. We show that this limit point x0 is a fixed, x bar is a fixed point of t. So now you see here, since t is a contraction mapping, by triangle inequality we have By again we use the contraction mapping. You see here. So finally we can find a d of x bar tx bar. It is dx bar xn plus alpha dxn minus 1 x bar. This tends to 0 as n tends to infinity. Before it we have already proved. So it will be dx bar tx bar is equal to 0. And so tx bar equal to x bar. So from here we can see here x bar is the fixed point of t. For the uniqueness, we can suppose p and q be any two distinct fixed point of t, and again use the contraction of t. You can show it. P equal to here dpq is equal to, again you see here, so it is equal to less than dpq. That is not possible, okay, because the same distance, dpq, it is not less than dpq. That is a contradiction. It means that both p and q both are the same. So this is the proof of the Banach contraction theorem. Now here some remarks. As you see here in the statement of the Banach contraction theorem, we consider x as a complete. So if we consider x is not complete, so what happened? So in this case, the mapping T may not have a fixed point. I have given an example. If you consider x as a 0, 1 with the usual metric, and T as defined as a x upon 2. So in this case, x is not complete metric space and T does not have any fixed point. So you see here T0 is 0. In fact, definitely T0 is 0, but actually it is not equal to x. As in the theorem, in the statement of the Banach contraction, I consider as a T as a contraction mapping. And suppose that if we did not take as a contraction, if it is not contraction, then what happened? Then again it is not may not have a fixed point. I have given an example, x equal to semi-closed interval 1 to infinite with the usual metric, and tx equal to x plus 1 upon x. Then in this case x is a complete metric space, but it is not contraction. So you see here tx minus ty, I have proof here, I have given the proof. So it is less than mod of x minus y for all x, y in x. So it is contractive but not have any fixed point. Okay. Yes, I am audible. So dear, see, application to a system of linear equation. So now suppose we consider a system of linear equation of n unknowns. Okay, here I consider the n equation and n unknowns x1, x2, xn. We can write this equation, this system of equation 1, like this. Okay, so it's easy to see. X1 you can write 1 minus a11 x1. Like this you can write a12 x2 minus a1n xn plus b1. By the same way you can write x2 and xn. So this system 2, if I consider here, if I denote alpha ij equal to minus aij plus delta ij, where delta ij is equal to 1 if we consider I is j, and it is 0 if it is not equal to j. So your above system of equation 2 convert like this: xi equal to j running from 1 to n alpha ij xj bi. So this is just how can you write the equation 2, system of equation 2, you can write like this form. In the matrix form, you can see if I consider X as a n tuples and a coefficient matrix, the coefficient we consider like this, a11, a12, a1n, like this. So in this case, in the matrix form, we can write X equal to ax plus b. So now you see, in another words, the problem is to find the fixed point of the transformation T from n tuples to n tuples defined by this one, Tx equal to, because you know we need to find the fixed point. So now we relate by using this transformation T from n tuples to n tuples. This is Tx equal to ax plus b. So this is the way that how can you can apply the fixed point on a system of linear equation. So here I have given some cases. Now here I consider, you see here, this is the note that is very important. You see, if T is a contraction mapping, then we can use the Banach contraction theorem and obtain the unique solution of this one by the method of successive approximation. Condition under which T is a contraction mapping depends on the choice of the matrix on X equal to Rn. So here I have given some example. If I consider X as a Rn, be a metric space with the metric here I define. It is also called the max metric. So here d infinite xy, it is equal to maximum of mod of xi minus yi. If summation of j running from 1 to n mod of alpha ij, it is less than or equal to alpha less than 1 for all I running from 1 to n, then the linear system 1 has a unique solution. So I have given its solution. So here you see, as we know that X equal to Rn be a complete metric space with respect to the metric d infinite, or you can say the max matrix. So we only need to show that the mapping T as a contraction mapping. So here the mapping defined by 4. So this 4 as this one, Tx equal to ax plus b. Okay. So we only need to show this T as a contraction mapping in our case here. So in this case, here. So we only know it is a contraction mapping. So by this you can see here d infinite tx ty, I have show here alpha d infinite xy. So here the some calculation according to you can see d infinite tx ty. So here I use the definition of the max norm, and then I use the theorem tx equal to this one here, this one third. Okay, j running from 1 to n alpha ij xj plus bi. So we can find like this. Okay, so here alpha d infinite xy. So in this case you can see this T is a contraction mapping. Now we can easily apply the Banach contraction theorem. So the so it means that it is a when you apply the Banach contraction theorem, so it the system have a unique solution with respect to this metric, the max norm. We can take the another metric, okay, and you can check. So in this case, if you consider the d1 xy, so this is also the by the same way, this have a unique solution. Okay, So here also, because of this one is the complete metric space with respect to D1 metric. So we only to show that with respect to this metric D1, T is a contraction mapping. So by the same example 1, you can see it. In example 3, D2XY, also you can see that this one is the complete metric. So again, you can show only the contract mapping with respect to this D2 metric. Now we come to the application to the differential equation. So how can we apply in the case of the in the case of the differential equation? So the first application is the system of linear equation. So as I show you that how can we apply the fixed point in the system of linear equation. Now here you see, as you know, that differential equation is much useful. So here we can apply the Banach contraction theorem in the case of the differential equation by using the transformation. I consider here a differential equation dy by dx equal to f of xy, and the initial condition is given x0 equal to y0. So you see the theorem that one is basically called the Picard theorem. If I consider f be a continuous function of the two variables defined on a rectangle a equal to here x y such that x is greater than or equal to a and less than or equal to b, and y greater than or equal to c less than or equal to d, and satisfying this implicit condition in the second variable, that is mod of f of xy minus f of xz, it is less than or equal to alpha mod of y minus z for all yz belongs to closed interval of CD. And also we consider x0, y0 be a initial point, interior point of A. So this is the initial condition. Then in this case, the differential equation 5, this 5 with the given initial condition have a unique solution. So here, actually by using the in the proof, we can make the transformation of the mapping T. Then we can apply the contraction Banach contraction theorem so for its solution. So it has a unique solution. So in this case it has also the unique solution. Now we come to the next application to the integral equation. So the most important application of fixed point theorems arise when the underlying metric space is a function space. Here we discuss the existence and uniqueness of the ultra integral equation by using the Banach contraction theorem. So here I consider let k be a continuous function on this closed interval AB cross closed interval AB, and let phi be a continuous function on closed interval AB, and consider the equation f of x equal to phi x plus tau integration over a to x kxy fy dy for all x in closed interval AB, where tau is a parameter. It is called the ultra integral equation or ultra equation. Now we see its fixed point formulation. So you see the theorem for each tau in R, ultra equation has a unique solution F, that is it continuous on closed interval AB. So this is all about the application I have given. This is the basic Okay, in the research point of view, it is more and more extension is there you can find. So dear, so now here I have given the some references. You can see the book. Uh, Actually in an C schedule, an introduction to the metric space crazy. This one is I think we use it mostly crazy. And actually in my, if you are talking about my research, so basically in my research actually we use the fixed point for this is the my publication. You can also see I use the fixed point formulation in the variational inequality equilibrium problem. So you can see it. Okay, so I have already mentioned here. Thank you so much.
Thank you, sir, for the vibrant speech.
Yes.
Now the turn for the participants. Our aim is to give a platform for interacting with the experts. So participants, please be free to ask any queries. I'm sure that a lot of postgraduate students are attending this webinar. And now for them, in the syllabus, Banach contraction principle is there. Then you can certainly have some doubts too. So be free to ask. If you're having any connection problem, please type in the chat box.
Actually, this is Dr. Rupesh.
Yeah,
actually, this is actually I have given the basic things. That is the by just motivational, huh?
yeah.
So, like for the research point of view, they can also see the how can I use the fixed point in. There are so many in the variational inequality equilibrium problem. Okay,
Yeah.
so but actually definitely we should know the basic things, otherwise we cannot apply.
Yeah.
So yeah, so that one is very important. So I just try to show that in the contraction, if you did not take the completeness, so what happened? If you did not take the contraction mapping, so what contraction mapping, so what happened? So we definitely we can impose the some condition. We can also take the contractive mapping.
Yeah.
In the case if you did not take the completeness, so in that case we use the compact, the matrix as a compact matrix space. So yeah, that one, just I introduce the basic things, that is the development of the fixed point. Okay. So I think those students who want to go to the functional, to do their research in the functional analysis, so they can also contact with me in future, and also we contact in we in your contact in future, so they
Okay.
can discuss.
Okay, that's great, sir. Dear participants, you have got a wonderful opportunity. He's offering us a wonderful opportunity. So, Faris, sir, can I ask you one thing? Can you suggest a few more topics regarding fixed theory in topologies? Because
Yeah,
because nowadays
yes,
the students are eager to search for the topic for projects.
yeah, yeah, in the next we can also discuss about iteration, fixed point iteration, and also the for the multi-valued mappings. Today we have discussed only for the contraction mapping,
Yeah.
contraction, Banach contraction theorem. Only one theorem, okay, we
Yeah.
discuss, and its application. Only one theorem in my whole presentation I have introduced, okay, just explain. So definitely there are so many here. Only I have discussed the metric fixed point theory, okay. So in the next, if you give me the chance, so we can also more explain about the multi-valued and also the iteration.
Okay.
You can also, as I again and again I repeat that you can also get the idea that how can I make the fixed point iteration for the equilibrium problem, the variational inequality problem, and also in the medical they do. So it is a not a it's broad area.
Okay.
Yeah.
Okay. Thanks, sir.
Welcome.
So, participants, I think there is no queries or doesn't need any clarification.
Maybe the students basically uh, they study, I think in PG this thing contraction theorem is there
Yeah,
in
yeah.
functional
Contraction theorem
analysis.
is there for them.
Yes, yes. And also in the metric space BSc final, in metric space the introduction is there.
Yeah.
Yeah.
And in the real analysis class too, they are studying about contraction map and all.
Yeah, we can for the PG student, if they are interested for the final, those one who are interested, we for the future we can think about the iteration, point iteration, and the latest theorem in the research. That one is definitely, if they are interested and they study about the functional analysis, then it's okay.
Yeah.
Otherwise,
So no queries or nothing seems. So I think all the participants are satisfied with this presentation. So let me invite Subhay sir to express the vote of thanks. And participants, I am posting the link for your feedback that is attached with your certificate. So to be free to fill that properly and submit it. Subhay sir.
Okay, sir. Thanks. So the aim of the seminar was to introduce the students the leading research area in that is in India and abroad, that is fixed point theory. That I think it was a very good success. Mr. Farid sir had discussed how to convert a general problem uh, to how to convert a general problem like a system of solution of linear equation like Volterra equations, problem to find the integral equations or differential equations, how to solve
Subesh sir, you are muted. Please unmute.
Dr. Farid sir nicely explained how to convert such a problem into fixed point theory problem or fixed point problem. So it is a leading area in the research in India and abroad. So he nicely presented. Now my I am going to my duty, that is for vote of thanks. First I thanks my college principal. He was with us to arrange this program and all the he supported, he gave all support to arrange such a program, and my heartiest thanks to our principal Dr. Assis sir. Next I thanks or my heartiest thank my colleague, and with a small invitation he he supported, and he presented such a nice presentation. Dr. Muhammad Farid, he was my colleague and my classmate. I was in legal university, and I worked with him with 5 year my MSc and MPhil program with Dr. Muhammad Farid. So I give more thanks or my heart is thanks to Dr. Varis sir. Or next, my thanks goes to all participants who participate from outside Kerala and inside Kerala. There are many participants from outside Kerala. They all faculty members and all students of different universities and different parts of India who participated in this program. I thanks my heartiest thanks to all the participants and all the participants and all people. I thanks my heartiest thanks to all the peoples. So with this news word, with these few words, I conclude my word of thanks. One more thing, your feedback form is in, I think, is in.
Yeah, already posted, sir. Already posted.
Your feedback form is in chat box. If you submit your feedback form, you will get the participation certificate. So please submit your feedback form, then you will get the participation certificate. Okay, sir. Thank you, sir. Thank you, Hari, sir.
Okay, thank you so much, Kunil.
Okay, thanks a lot,
Thank you
Farid,
so
sir.
much. Yeah. Thank you, sir, Dr. Sir. Thank you
Okay,
so much.
then I thank all the faculties who has attended this and all the participants. Because of you, this will become a great success. Thank you all.
In the last, I would like to say, in future, if anybody want to do in the fixed point and in the collaboration, so no problem, they're welcome.
Okay, thanks a lot.
Thank you so much. Thank you so much.
Okay, meet you soon, sir.
Okay, thank you so much.
Thank you, thank you. So participants, I think you have submitted your feedback form and got the certificate. And if there is any issue, please let us know.
Can I leave, sir, or
Yeah. They are having no queries, no. Then you can leave, sir. No problem. Thanks you. Thank you. Thanks a lot,
Okay.
sir.
Again, thank you so much, sir, for giving me this opportunity.
Okay.
And your kind
You're
words,
most
sir.
welcome, sir.
Okay. Okay. So
Okay.
thank you so much.
Thank you. Take care. For the participants, this is going to be our first international webinar series, first seminar. We are planning one more thing in the coming month, that is January. So I hope all of your participation in that too. Thank you. Thank you a lot.
Once again, please tell them for feedback and their certificate.
Yeah, that we have already mentioned. So please don't forget to submit your feedback forms. So within seconds, you can get your certificate in your mail. So check your mail, and if there are any difficulty means, let us know. So can we leave now? Okay, anybody want to share something? Or anybody want to supplement something like a fixed point theory or something? Okay, in chat box there are lots of thanks is coming. Okay, thank you so much. You are most welcome to all of you for the next international webinar too. Thank you, thanks a lot. So we are leaving. Once again, thank you all.